Welcome to another lesson in grade 9, angles of triangles, specifically angle side angle congruence criteria, and we're going to go quickly into the examples. For number 1 to number 6, the requirement is that you need to prove the triangles being congruent. So we already know that we can either do a flow proof or we can do a two-column proof. Most important in doing any proof is to always go and write down what is given. That will award you marks. And the next point that will award you marks is when you write the final statement, what you are proving, right? So you would already get 3 to 4 marks basically by writing down what is given and what you have to prove. So in each example, always go through and see what information is given, highlight it, write it, fill it into your diagram, and see how you're going to prove or what reasons you are going to use to prove that the triangles are congruent to each other. Remember, don't ever forget that when you have two triangles in a quadrilateral, then this side here is always your reflexive. So this is a common side, which means that it will be equal to each other and use reflexive property. When you have the letter X, we know there's the letter X, you have vertically opposite angles which are equal. So here it will be vertically opposite angles. So pay careful attention to this. And thereafter it's very easy. Always look at what's given. This is a 90-degree angle here. So if the one side is 90 degrees, it means the other side will obviously have to be 90 degrees. Moving forward, in this example here, they say two doorstops have cross sections that are right angles. So we have the right angles here. Both have a 20-degree angle. So there's your 20-degree angle here. And the lengths of the sides between 90 degrees and 20 are equal. So they are saying that this X is equal to this X. They ask us if it is congruent. Yes, they are congruent because you have angle, you have the angle, you have the side, and you have the angle. The next part of this question is very important. If each cross section has a height of 2 inches, so there's my height, it is 2 inches, both my diagrams. And X is equal to 5, so replace X with 5. And then they ask us, what is the combined area of the two cross sections? And we know that to calculate area, we use a specific formula, which is A equals half base times height, half base times height. And if you have to substitute that and calculate, it will be half multiplied by your base, which is 5, multiplied by your height, which is 2. And then this would give us 5 inches squared. Now remember, they ask us what is the combined area of both. So it will be 5 plus 5. Which equals 10 inches squared. 10 inches squared. So whenever you're given a question, always remember, go and see what is given, right? And fill in the information and check what formulas are required. Going to the next example. See what is given to us. It tells us line segment AC is parallel to BK. B is the midpoint, so we know midpoint is always the middle. and then you can conclude whether they are congruent or not. You need to check what information is given. But more importantly, in this question, I want to focus on the fact that they say triangle ABC is equilateral. So go to triangle ABC, and they say it is an equilateral triangle. So ABC, that means we know that all these sides are equal. Thereafter, they tell us that AB is 18.5. So go to your diagram, fill in 18.5. Whenever information is given to you, go to the diagram and fill it in. And you would find that it makes it much more easier to see the information. So now we can conclude that if AB is 18.5, AC and CB will also be 18.5. But the question here is focusing on what is the perimeter, right? So they don't want area here. They're looking at perimeter of quadrilateral ACKB, ACK and B. So they want the perimeter of this. So we know that if this AB is 18.5, then all the other sides will also be 18.5. You can go ahead and either multiply it by 4, or you can add it 4 times, and you would be able to calculate the perimeter. Remember, perimeter is the distance around the object, right? The total distance around the object. So you would need to add all the distance that is given to you. When you add the distance, it will give you the perimeter. I hope you have enjoyed this part of learning and it is much more clearer. Please continue to practice, and as usual, remember, push yourself because no one else is going to do it for you. Take care until our next lesson.